Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss Fresnel diffraction pattern of a wire. Let's begin. A source S, here is a slit, that one is a rectangular slit. Source S produces monochromatic source of light. Monochromatic source of light having wavelength lambda. And we place a screen here. A wire is situated in front of that source at a distance x from that of screen. Here x is the distance between slit and screen. Let d be the thickness of that wire. D is the thickness of wire. Light rays passing here that region is the geometrical shadow region. At the center of that screen O. The geometrical shadow region. After that, these regions are illuminated regions. From that of source, we take the wave fronts. Let that wave front is the cylindrical wave fronts. X, that wire named as AB, X, Y. Here AB is the wire, XY is the wave front. Let you take a point here P x p y. P is the point which is the pole of that wavefront with respect to O. P is the point which is known as pole of the wavefront with respect to the point O. But experimentally we found that in that of geometrical shadow region there will be an alternate dark and bright fringes obtained, and also in case of illuminated regions again we observe bright and dark bands here. Why that happened? Look that figure. Here and there, x a and y b, that portion is also act as a straight edge. This portion is also act as a straight edge. So, diffraction at straight edge phenomenon is introduced at that particular case. So, here due to that straight edge we have the diffraction inside that of illuminated region, and again at that portion due to the concept of diffraction at straight edge also we found the diffraction pattern at that illuminated region. Again the point A and point B, the wavefront from point A and point B are same in phase. Therefore, these 2 points act as the coherent sources. Due to these 2 points act as the coherent sources at point O, the path difference will be 0. So, at point O we obtain the central bright one, and the phenomenon of interference is executed in that of geometrical shadow region. Overally, in case of where we have the interference pattern inside this geometrical shadow region and diffraction pattern in that of illuminated regions. How we explain these points? There are 2 kinds of wires. One is thin wire and another one is thick wire. In case of thin wire, where d is small, we obtain the interference pattern inside that of geometrical shadow region. But in case of thick wire, there will be the interference pattern, but that interference pattern can't visible as the fringe width is very small. Therefore, in case of thick wire we can't obtain the interference pattern, but we observe the diffraction pattern inside that of illuminated regions. Let me point out these points. How Fresnel used his assumptions as Fresnel's half period zone concept to show the diffraction pattern of a wire. In case of thin wire, only some half period elements of the upper half and lower half of the wave front are obstructed. In case of thin wire, at all points above the illuminated region on the screen, the obstacle produces the same effect as straight edges. So, the diffraction bands are formed in the illuminated region. In the illuminated region, due to some half period elements of the upper half and lower half of the wave front are obstructed in case of thin wire in upper half and lower half, and these upper half and lower half act as straight edges. So, the diffraction pattern due to straight edge we obtain in that of illuminated regions, upper and below illuminated regions on that of screen. So, at all points above the illuminated region on the screen, the obstacle produces the same effect at the straight edge. So, the diffraction bands are formed in the illuminated region. In the illuminated region, we obtain the diffraction bands due to the straight edge concept. Next point, also we obtain the interference pattern inside that of geometrical shadow region. For that, we write the upper half of the wave front above the wire acts as one source whereas the lower half of the wave front, the lower half of the wave front below the wire acts as another source. These two sources act as two coherent sources. These two sources acts as two coherent sources with respect to any point on the screen, respect to any point on the screen in that of geometrical shadow, in the geometrical shadow. Thus, we obtain the interference fringes. Thus, the interference fringes are formed due to two coherent sources, due to two coherent sources. Therefore, the fringe width beta is represented as x lambda divided by t, x the distance between the wire and the screen, d is the thickness of the wire, lambda is the wavelength of that of monochromatic source. In case of thin wire, we have that point treated as a source, that point also treated as a source. These are coherent sources. Due to the coherent sources, we obtain the interference pattern in that of geometrical shadow region. As we write it, the upper half of the wavefront above the wire act as one source, whereas the lower half of the wavefront below the wire act as another source, and these two sources act as two coherent sources with respect to the point on the screen in that of geometrical shadow. Thus, the interference regions are formed due to the two coherent sources. These 2 points are responsible in case of thin wire. So, what will be the intensity distribution? We show that of intensity distribution, let I figure out. That portion is the geometrical shadow region, that is the illuminated region, that is also the illuminated region. So, here obtain the interference pattern just like this. In this region, we obtain the diffraction pattern due to the straight edge. This is the intensity distribution of diffraction pattern due to straight edge, and here we obtain the interference pattern inside that of geometrical shadow region. After that, also we obtain the diffraction pattern due to the straight edge. This is the illuminated region, that is also the illuminated region. Here, that is the shadow region. That will be the distribution of intensities in case of thin wire. Another case, case number 2, what we have seen in case of thick wire. in case of thick wire, the fringe width concept, if D is very large, therefore fringe width will be minimum. For thick wire, D is large, therefore the fringe width are very close to each other. In case of thick wire, due to increase in diameter of that of wire, the fringe width inside that of geometrical shadow decreases. When the wire has very large diameter and becomes sufficiently thick, then the fringes inside that of geometrical shadow disappears completely and the intensity diminishes from the edge of that of shadows as we move deep into the shadow region. Right here, in case of thick wire, as diameter of the wire, diameter of the thick wire is large, as D greater, then beta decreases. When D increases, beta decreases. So, inside the geometrical shadow region, the interference pattern disappears completely. Here there will be the formation of alternate dark and bright fringes, but due to the concept of fringe width, so the fringe width are very small, so we can't detect the alternate dark and bright fringes in case of thick wire. So, the intensity distribution inside that of geometrical shadow region, alternate dark and bright bands are completely disappears. Inside that of illuminated region, we also take that of diffraction pattern due to the straight edge. So, with the help of this video lecture, we understand the concept of Fresnel diffraction pattern of a wire. We have two cases, in case of thin wire and in case of thick wire. In case of thin wire, we have the diffraction pattern at the illuminated regions due to the concept of straight edge and use Fresnel's theory of half period zones. And again, interference fringes inside that of geometrical shadow region as A and B act as two coherent sources. And in case of thick wire, the interference bands or interference pattern are completely disappears. These are the graphical view of intensity distribution of wire, that for thin wire, that one for thick wire. So, with this useful and informative notes, let me wind up this session. Thank you.